Okay, this is lesson 6.3, variation and modeling. With direct variation is when you have something that's only multiplied by something. For instance, our equation form, our equation form is going to be y equal to kx, where it's only multiplied by something, it's not adding or subtracting anything. So y is directly proportional to x is some wording you would see. Sometimes you see it written as y varies directly with x. Let me fix that. K, that variable k is called our constant of proportionality. So what you're going to need to do is recognize the wording. Whenever it says direct variation, then you need to know that that's the form, y equal kx. You're always going to put a k in there, and it's always going to be in the same format. So let's look at a problem. So for instance, on example 1, y varies directly with x. If y is equal to -4 when x is 2, find y when x is -6. So this first sentence right here tells us it's y equal kx. And then we're going to use this next bit of information to find out what k is. So y is -4 when x is 2. So we plug that in there. And then we solve that to find out what is k. And if we divide both sides there by 2, we get k is -2. So now I can write my equation. My equation would be y equal -2x. Okay, so this is important. You need to be able to write the equation. And then after you have the equation, now we're going to actually find y when x is -6. So basically all I have to do is plug in -6. And so I know y is 12. So this answers the question. So I'm wanting to see both of those things that I boxed in there. Now it applies even if it's not those exact words. So notice how in this next problem, we're talking about force. The force F exerted by a spring is directly proportional to the distance that it stretched. So that means F is equal to kg. Okay, this directly proportional is our k. That represents our k. We're multiplying by something. We just don't know what it is. Now they're asking us to find the constant of proportionality, so we're finding k on this first part, and we're going to write the equation. So let's see. We've got F is 12, G is 1/3. So 12 equal to k times 1/3. So here I would multiply by 3 on both sides, so I know k is 36. So this is the first answer. Now then they say write the equation. Well, that's easy now that we have what k is. F is 36d. All right, so that is direct variation. Now this next part is inverse variation. It's very, very similar. What's different here, though, is it's dividing by something. So you have y equal to k divided by x. So very similar. Instead of multiplying by something, you're dividing. And the wording for this would be y is inversely proportional to and k is still our constant of variation. That's the same in all of these, okay? Our constant of proportionality, our constant of variation, same thing. So notice on example 3, y varies inversely with x. So that means y is equal to k divided by x. And then we're going to solve, let's see, if y is 40 when x is 16. So 40 equal to k divided by 16. So if I were going to solve for k, I'd multiply both sides by 16. So k is 640. And now we need to find x when y is -5. So my equation here is y equal to 640 divided by x. This is our equation. It's important that you can write that. A lot of times that's what they're looking for in a word problem. And then if we plug in this next one, find x and y is -5. So -5 is equal to 640 divided by x. So let's see, if we cross and multiply there and multiply both sides by x, -5x is equal to 640. Divide by -5, and I get -128. All right, so the next one, example 4. The note played by each pipe in a pipe organ is determined by the frequency of vibration of the air in the pipe. The fundamental frequency, F, of vibration of air in an organ pipe is inversely proportional to the length of the pipe. So F is our frequency. This would be K divided by L. So you're looking for those words to tell you how to set up that equation. So now we are looking for the fundamental frequency of a 1.6-foot pipe if the fundamental frequency of an 8-foot pipe is this. All right, so we can use that to find our equation to find out what K is. So the frequency would be the vibration, so 64 is equal to K divided by the length of this thing, which is 8. So, I'd have to multiply both sides by 8, so K would be 512. So my equation is F equal to 512 divided by L. So now we're going to solve the question here. We're going to find the fundamental frequency of a 1.6-foot pipe. So F is equal to 512 divided by 1.6, and that gives us 320. So that would be our vibrations per, what is that, seconds? Yeah, vibrations per second. Alrighty, let's see what else we have to do. Okay, so this next part is called joint variation. And joint variation is the same thing as direct variation, only it's got more than one variable involved. So here we would have, say, W, oops, I'm on the wrong one. Let me erase that because I don't want it to be highlighted. Okay, here we go. W is equal to KXY. We're still multiplying by the same thing, but now there's just more than one thing that we're multiplying by. And so you would see the words as W is jointly proportional to X and Y. K is still your constant of variation, as it is on all of these. I'm trying to make that a little bit better. I'm so glad you guys can write like a lot neater than me. All right, so example 5, the volume V of a right circular cone is jointly proportional to the square of the radius and its height. All right, so volume is equal to K R squared H. Find the equation of variation if a cone of height 8 inches, radius is 3, has a volume of 24 pi cubic inches. All right, so let's see. Volume is 24 pi. K we don't know. R is 3. Height is 8. All right, so let's see. This would be 24 pi equal to, that's 9 times 8, that's what, 72? So if we divide by 72 and then simplify it, don't we get pi over 3? Or like 1/3 pi, basically same thing. So volume was equal 1/3 pi r squared height. And you might recognize this formula, because that is the formula for a circular cone. We just solved it. Okay, so let's look at the next one. The frequency F of a vibrating guitar string is directly proportional to the square root of the tension T and inversely proportional to the length. All right, so let's write that up. Frequency F, directly proportional, so K square root of T, so square root of T, inversely means I'm dividing to the length. What is the effect on the frequency if the length is doubled? Oh, let me go to a different color because that looks kind of interesting. The length is doubled, tension is quadrupled. Let's see here. So F is equal to K. We're doubling the length and quadrupling the tension. Quadruple means times 4. So this is 4T and 2L. Double is times 2. Well, can I simplify that at all? Oh yeah, square root of 4, isn't that just 2? So this would be 2K square root of T over 2L. Well, those 2's cancel out. So I'm left with just K square root of T over L. Well, that's the same exact thing that I started with. So there would be no change. No change at all. It remains the same. Well, that's interesting. All right, so let's look at the next one. Okay, the next part is looking at combined variation. Now, combined variation is when you combine them. Basically, we just did that in example 6. So I don't know why they didn't put this ahead of it, but it's just a combination of direct and inverse variation. Okay, so if you have multiplying 1 and dividing 1 together, and that's what we did in example 6. All right, so this next part, let's see. These are ones for you to try on your own. If you want to pause the video and try it, that'd be great. See if you can write it in and get what I got. Let's see. The electrical resistance R of a wire varies inversely as the square of the diameter. So R inversely means I got to divide, square the diameter squared. All right. Number 2, frequency of sound, F, varies directly as the square root of the tension T, inversely as the square root of the mass. Wow, that one's kind of interesting. Okay, so F directly, so I need a K. Well, I need a K in all of them. Square root of tension, square root of the tension T, divided by the square root of the mass. Okay, number 3. W varies jointly with X and Y and Z. If W is 36, when X is 2, Y is 8, and Z is 12. Find W when blah, blah, blah. Okay, so let's write the first one. W varies jointly with X, Y, and Z. So W is equal to K, X, Y, Z. Oh, wow, we got a lot of values here. So we need to find K. So 36 is my W. K, we don't know. X is 2. Y is 8. Z is 12. So 36 is equal to 192K. Divide by that. Ooh, that's the decimal. Okay, so leave it as a fraction. So do not round. Do not round. If at all possible, don't round your K. Okay, I know you want to and put it in there. Just leave it as a simplified fraction. Because if you round K, you may have a round-off error later on when you go to work the other part out. So do not round. So my equation now is W is equal to 3 X, Y, Z divided by 16. So when you write it, please don't put a fraction inside a fraction on the top. That top number goes with all the things on the top. That 16 would go on the bottom and everything on the 16. So this is my equation. So I need you to be able to get to that. And then we're going to solve it. I'll change our color. We're going to find W when X is 1, Y is 2, and Z is, oops, I accidentally changed that thing. And Z is 4. So W is equal to 3 times 1 times 2 times 4 divided by 16. Let's see. 3 times 2 times 4 divided by 16. I believe that simplifies to 3 halves. You can double check that for me. All right. We are finished. So we still have, the class day on Monday to go through the homework, so you'll be able to answer or ask questions in, and I'll answer those, anything that you have at that time.